We had a big situation yesterday.
This example is going to run alongside so that you see that all the steps are exactly the same, whether I'm dividing polynomials or whether I'm dividing real numbers. Are we ready to go?
No.
Yes, we is.
Ready or not?
Yeah, can you
Okay.
do regular division though?
Let me just say this. Let me remind you. If you have something like this, okay, that means 3 into 2, right?
Yeah.
We understand that the number on the bottom of the fraction goes outside the house, right?
Yeah.
And the number on the top of the fraction goes inside the house, yes?
Yeah.
Okay.
Oh no, my eyebrow raised really big.
Yeah.
I didn't like that
I drew
means
my
bad
house just
things.
now, it's
and I
just
just
been
don't.
square.
Let's do, I think the easiest way is to start out with an example, show you how it correlates to regular long division, and then go from there. First thing I want to tell you is about a placeholder before we actually divide. If I have a polynomial that looks like this, I need to start at my biggest exponent and make sure that I have every exponent from there all the way down. So looking at this one, do you see what is missing?
Third.
The third power. So what I would need to do whenever I go to divide is I need to put in a placeholder here. I would just put plus 0x cubed. Okay. It literally does what it says. It holds the place of each term that's not represented. Each exponent that's not represented. Does that make sense? Okay.
Makes sense.
Does it make dollars, Justin?
No, or I mean,
Yeah.
get a
It
job in
makes
math.
bills.
I didn't remember you put it there.
Donovan.
Yeah.
All right.
So,
Okay, wait. Okay. Donovan, give me your problem.
function of x equals x cubed plus 5x squared minus 7x plus 2 by x,
Divided by.
x minus 2.
Does not look like your old long division problem, right?
No.
All right, first things first, does it need a placeholder?
No.
No. Why, Isis?
Because it descends
3, 2, 1, nothing, okay? All right, so let's set up our little house. X minus 2 goes on the outside.
We'll end up writing square roots on something.
I will tell you,
That's exactly where I missed it.
your neatness is whether you're going to be successful or not in this,
Oh
okay?
man.
You have to keep your columns straight. You have to keep everything together that goes together. That makes all the difference.
Okay.
All right, inside the house goes x cubed plus 5x squared minus 7x plus 2. Okay. All right. Take a gander over at the long division problem on the left side board that some of you on the right side of the room cannot see. However, it says 9 into 745. What is the first step in that problem? What do you, if you're telling someone who has never in their life seen that before,
You look at your 9
you look at your 9,
and see if it can go into the first place.
see if it can go in the first one, and in this case, it's going to be the first
2, yeah.
2, right? And what do you do from there?
Yeah.
How many times do you multiply 9 to get closest to 74, right? 8, and you put it where?
On top of the 4.
On top. All right, let's stop at that first step and let's look at our polynomial. The only difference here I'm going to tell you is we're going to only use when we're looking this outside term right here, this x, okay? Looking at the x and looking at the x to the third. How many times does x go into x to the third? Or, not 3, but 2.
Why not?
Cube.
Or, what do you need to multiply x by to get x cubed? 3.
2.
3 times x is
squared.
3x. X squared, right?
Oh,
Are y'all following me? Right.
The exponents, they gotta add.
Yes, yes. All right. Now here's be neat. This column's gonna have nothing but cubes in it. This column's gonna have nothing but squares in it. This is gonna be all x terms and this is gonna be all constants.
Anyway,
So, what do I multiply this by to get this? And we said x squared, so I'm going to the squareds column and I'm gonna put an x squared up here. Just like I did my regular division problem, okay?
okay,
Tell me the next step here.
then you, to multiply the,
You multiply. You're jumping ahead, Colin, but you're right. I multiply and I get what?
72,
72, where do I write it?
under 74.
Okay, hold up right there a second. I'm gonna multiply this just like I did there. Here's the problem. It's gonna, does it work now? What did she say?
Said it might be broken.
Okay, so here's the difference. Now, I've got to multiply x squared by everything on the outside. Okay, so it's gonna be x squared times x, which is, again, this is my cubes column. And then it's going to be x squared times -2, because really this is x squared times x minus 2. It needs to multiply to everything back there, okay? Is anybody confused at this point? Where do I lose you?
Well, why would you?
I multiplied this here, just like I multiplied 8 and 9 over here. I multiplied this to both of these.
So it was kind of like
And then
you subtract.
It is exactly distributed.
Okay.
That is exactly what it is.
So this would be, and then you'll have 3x.
Wait, how did you get?
All right.
You did the x squared times the x. Oh, wait, that's going to. Never mind.
All right. This is overwhelming when you first see it. By the time we get to example number 2, you'll go, oh my gosh, this is not even hard. It's just long. Okay? Trust me, stay with me. Look back at our problem on the left board here. What is your next step?
Subtract.
I subtract, right? I'm putting this in parentheses for a reason.
Because that's what we're gonna do.
Because here, remember, we did a lesson on multiplying polynomials. Then we did a lesson on what we thought was very easy, but it was adding and subtracting polynomials. Because what I'm going to do is just like I subtracted there, I'm going to subtract here. Okay? So, those of you who don't like same change, I'm sorry. I like that in these kind of problems. I'm going to leave this one alone. I'm going to change. Now, if you've done it correctly, the first terms will cancel out. What is 5x squared and 2x squared?
7x squared.
All right. I'm caught up with the same problem. Come over here. What is your next step after you subtract?
Bring it down.
Bring the next number down, right? So I'm going to bring the next term down.
So 7x squared minus 7x.
Yes. So I'm going to drop the negative 7x. And then what happens? What do you do in normal long division?
Again.
You just start repeating the same process, right? Only now, instead of looking here, you're looking here, right? So, I'm sorry. What do you multiply 9 by to get 25? 2? And the process continues to repeat, right? 25 minus 18 is 7. And we'll get back to what we're going to do with that. But let's finish this process out. Let's finish these repeating. Again, looking only at the first terms. What do you need to multiply x by to get 7x squared?
7x.
7x. Positive 7x goes in the x column. What do you do now?
Multiply.
Multiply around. Now when you multiply around, it's got to hit everything on the outside. So 7x times x is what?
7x squared.
7x squared. It goes under the squareds. 7x times negative 2,
Negative 14x.
that goes under the x column. I'm subtracting all this. The first two should always cancel out for you. Same, change. First two are done. I've got negative 7x and 14x. Positive 7x.
That's right. Drop down that next term. I think these are fun because they're not real hard, but they look like if somebody sees you doing it, they go, "Oh my gosh, what are you doing?" But it's really, I like it because it's exactly the same concept as what you learned before. I mean, exactly. It is step by step. The only difference is there's variables now. I told you it's very intimidating when you see it, and everybody goes, "Oh my gosh!" But by the time we even get to the end of one example, there's so much repetition in it that it's really a total of like 3 different steps you're doing over and over. All right, so now again, first terms only. What do you multiply x by to get 7x? That goes in the constants column. Multiply it around. What do you get? 7x
7x
minus 14.
minus
That's exactly
14.
right. Now, I've hit a little bit of a hiccup here because I don't have anything to bring down, and I know that there's nothing I can multiply x by to get 16. So tell me what that number is called.
Is
What is that number that's left over? Yes,
A remainder.
The remainder. Now, tell me this. Riddle me this, Thompson. I don't want to put R7 up. Okay, that's really kind of not on my level. We're a little beyond that. How else can, besides making a decimal, and going, how else can you express the remainder? As a fraction. You're exactly right. It's not, no. 7 over what?
X.
16 over x.
So technically I could do a plus 7 over 9. That's the remainder.
Where you go like, you take a 7 and just do the little spin around.
And then it's the way
So look at mine.
So I put mine.
I'm at 16 over x minus 2. Where did the thing below that come from?
I multiplied 7 through. What do you multiply x by to get 7x? And it was 7.
Yes. What's the 7
Multiply
to?
them,
I
right?
was thinking,
How'd you get 7?
so is it 16 over x minus 2?
Yes. You're absolutely right. See, it's not bad, right?
Okay.
So it's remainder, yeah.
You get 7x, which would, that would go with the 5x squared, right?
Say again?
Where did 7 come from?
7x.
That is top.
It's what you multiply.
The blue 7x is, you're looking here, what do I multiply this by to get this? Olivia, what did you say?
I was asking where that 7 came from.
Yeah.
The yellow 7?
Yeah.
So the yellow 7 came from what do I multiply x by to get 7x here? Yes, Isaac.
Do we need to put it down anymore, or do we need?
That's it. That's the answer. It's done. This, when you divide these two, you get x squared plus 7x plus 7 plus 16 over x minus 2.
Okay, I feel good about
I
it.
can tell them to make.
I'll give you
Give me the next problem. Set it up. Okay, yeah, go ahead.
2x to the 4th plus x cubed plus x minus 1 divided by x squared plus 2x minus 1.
Should I not finish when the bell rings? Sit tight. If I make you late for 4 o'clock, I will write you a tax. Just stay with me.
Right, my pass by.
Okay.
Tell me it's gonna take 20 minutes.
10.
Well, 13.
Yes.
It's taking longer.
Okay. The number after the division sign, also known as the bottom of the fraction, goes on the outside of the house. So I have x squared plus 2x minus 1. Now several of you said you didn't understand about placeholders. Look at this polynomial.
You need a 2.
You need a 2. So I'm going to do 2x to the 4th plus x to the 3rd plus what? 0x to the 2nd plus x minus 1. Does that confuse anybody?
Yes.
Why? Where?
Well,
What?
I don't know.
I had 4, I had 3, I didn't have a 2, but I had a 1 and a constant.
I understand.
Why don't you make it a 1x squared instead of 0x squared?
Because 1x squared has a value. 0x squared doesn't have any value.
Okay.
Oh,
Because it's gotta be.
I squared the x, not the 0. I squared it because it's holding the place of all the squareds. Because remember, all my columns are lined up. If you look back at your other, I need a column for squareds, and I didn't have one. All right,
No, I'm good.
So like, say you didn't have a column for cube,
you would put the cube there. Yep.
Okay, that makes sense.
You said that,
Added the whole
part
thing.
because of the third is?
Yeah.
Alright, so we're gonna like,
Not today.
just
Are
do
we,
this.
are we working?
That'll be on our homework.
Yes.
We have
All
to-
right. What do you multiply x squared to get 2x to the 4th?
0x squared.
Woo! What?
2x squared.
2x squared. What do I, listen again, Evan. What do I multiply x squared by to make it turn into 2x to the 4th?
2x squared.
2x squared.
I know
It
we have to
goes
use-
over the 0x squared. Because that column
Because
is
that's
where
how
all
it
my powers
works.
of 2 are going to be. This column's going to be powers of 4, powers of 3, powers of 2, powers of 1, and constants. Okay? Multiply around, but when you multiply around, make sure you distribute to that entire polynomial that's out there, okay? So, 2x squared times x squared.
2x is 4.
2x squared times 2x. Positive 4x cubed. 2x squared times negative 1.
Negative 2x squared.
That is correct.
And then there's subtracting all.
Just like regular long division, I'm going to subtract. But I'm going to subtract this whole polynomial. Oh my goodness.
Don't do the same thing.
Yes.
For everything.
I'm going to change. The first ones cancel out as they should, right? Yes. What is x to the third and negative 4x to the third? Negative 3x to the third. What is 0x squared and 2x squared? What do I do now? Drop down the next term. Again with the same process over again, only this time, yes, Colin.
How did you get 2x squared at the top?
You're looking at what do I multiply the x squared by to get the first term inside? X squared times what gives you 2x to the 4? So now it's the same thing, only this time it's x squared times what will give me, so what is it? Multiply around. Make it hit everything. Be careful, this is a negative 3x, right? So that's what I'm multiplying by. And if it's easier for you to come off to the side and say negative 3x times x squared plus 2x minus 1 and distribute it through like that, then do it. 3x times, or negative 3x times x squared is negative 3x cubed. Negative 3x times 2x is and negative 3x times negative 1 is subtract. Same, change. First ones are gone. 2x squared and 6x squared. X and negative 3x. I got something else to bring down. So now my question becomes, what do I multiply this by to get this? 8. Positive 8.
Wait, so you're always gonna multiply, you're always gonna use the
First terms only. First terms only, always. Write it down. Remember. All right, multiply through. 8 times x squared. 8 times 2x. And 8 times negative 1.
-8.
I am almost done. I promise I am. Y'all are starting to sound a bit sad.
I am so.
Don't be sad. Be happy.
I'm not really feeling this calculus class today.
Change, 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 change. First ones cancel as they should. I've got negative 2x and 16x, which gives me What's it give me?
18x.
negative 18x plus 7. Nothing else to bring down. And I definitely can't multiply x squared by anything to get negative 18x, so that means that is my remainder. So whenever I get a remainder, I say plus, I take that remainder, and I put it over the polynomial that sits on the outside, and I'm done. It looks worse than it is, though, because really you're just copying that. I think that's